Recently, I sold my bare bones 6502 single board computer, a PAL 1, to a friend. He wanted to do some experiments with it, and I'd pretty much done everything I was going to do with it. So I let it go. But then I was kind of running into some problems. It's like, well, I really would like to try that in Focal, or hey, I wonder how that works in 6502 code. Because as you know, my Hassler's Monster machine runs on a 6800, 6802 to be precise. So I figured, well, I'm going to need something. I guess I better make something. So I made this. This is the GS6. And I'll tell you all about it in just a minute. But first, I have a confession to make here on...
Hey kids, it's the 6502 show.
I have an awful lot of junk. I got sockets and parts and chips and wire crap, just about anything you'd want to think that you could have if you wanted to do some electronics. I've got some pieces and parts that'll do it. Considering the pile of junk that I had laying around, plus a very head-crashed 1541 disk drive, I thought, well, I got some parts here. There's stuff I can do with this. And the design that I chose was the Grant Searle Simple 6502. He's got a number of different designs on his site that kind of follow the same thing for like a 6809 computer, if you want to build one of those, a Z80 computer. It's really neat stuff. He's had them up on the web for, 15 years now or more. And you can go to his site and check that all out. He doesn't allow any use of his website on other web things. So just go to his website for the schematic and some other information. It's all right there. I just thought I'd make a little drawing here and show you all what I changed. You can look up the schematic on his website. Link is in the description. It's on the screen. You can see it all there and then compare to what I've done here. First off, I got rid of this crystal and inverter business because I had a full-sized CAN oscillator. And we just used that and fed that straight in to the flip-flop to get our 921 kilohertz. Now, he shows that you could probably just take this output and feed it directly into here and directly into the CPU, just bypass the flip-flop altogether, which, if I have a 65 CO2 that will run at 2 megahertz, I might drop that in and we can do that. If I can find a 68B50 ACIA, that'll just drop in and that will run just fine. And often, the components will run faster than rated, but I don't want to push it. So you can see the addressing here and how that works. Didn't even have to mess with a Max 232 level shifter because I already have a TTL to USB cable that will work just Jim dandy. Let's take a look at the physical machine itself, the Grant Searle 6, the GS6, right here. Built on a piece of strip board. That's what it looks like on the back, my friends. It ain't pretty, but you know what? That's not bodge wiring. That's modern art. Here are some close-up pictures of the strip board, and, before I did anything. And on the back of it, you can see how this works. I mean, it saves a lot of wiring, actually. And it's pretty handy. A little limiting, but one thing that we can see to break some of those limits, if I hold this up right here, I've dremeled out, and it's underneath this sticky pad, felt pad here, but I've dremeled out part of the strips here, so in case I ever wanted to add a 34-pin head connector there so I could do some expansion, well, then that certainly could be done. All right, overview. We've got our CPU hauled out of the dead 1541 drive. We've got some RAM, got some ROM. This is an EEPROM. It's an 8K, even though I've got 16K of space, just using the bottom of it. The only time I use the whole 16K is when I'm running Enhanced Basic, Lee Davidson's language. We got a 1.8432 crystal. We're dividing it by half with this flip-flop here. Got a little logic, a double aught. And finally, our ACIA right here. Other than a simple temperature-controlled soldering iron, my test equipment consisted of this here logic probe, this here Hanmatech tiny one-channel oscilloscope. It's good up to 20 megahertz, so good for anything I'm going to do with my retro computing hobby. And a, I think, $4.99 Harbor Freight digital multimeter. Digital oscilloscope, wouldn't that be something? With simple tools, $60 oscilloscope, you can build this stuff. It's not difficult. Look at the chip count. Look at the schematics. You can do this. Good question, Mary. I'll tell you this. The first thing was to get a monitor going. I found the source code for a version of Wozmon that uses a 6850 ACIA. A few tweaks, translations, adding in an S-record loader, and I had it running on the machine. I was going to be able to get code in and out of it on a serial interface. From there, it was just a matter of adapting some languages and tools that would work with my hacked-up version of the Wozmon. Just for the halibut, I decided to run David All's benchmarks for floating point accuracy and randomness on the 3 high-level languages that I hacked together to run with the GS6. We've got Microsoft's MOSTech Basic 1.1, Focal 65, and Enhanced Basic, which I still love to call A Basic. A. And as we can see from after running those benchmarks, the accuracy of the Microsoft product is very good. And it's actually the same as it would be on, say, a Commodore PET or a Commodore 64. It's the exact same basic. An Apple II, for that matter, it's going to be the same. Randomness is solid. Voidstar, whose website I referenced down here, he said that basically any randomness figure under 30 is going to be perfectly fine for anything we're going to do. So I added a couple of comparisons from his explorations, some contemporary types of software languages and how they performed. But it's all pretty good. A-Basic is fast when it ran these benchmarks. 1,000 squares and 2,000 randoms. Focal, again, took quite a bit of time, but so did the Microsoft MOSTech Basic. This is the basic that was for the Kim 1 way back in the late 70s, colloquial known as KB9, Kim Basic 9-digit precision. I also, because these 3 down here at the bottom could not run the accuracy benchmark, they don't have a square root function. You could write them in BASIC, write them in machine language and call them, but it's not going to be the same thing. That's comparing literally apples to pomegranates and possibly to maybe pork loin. I don't know. But we've got the integer basics here. Tiny Pilot is integer only. Tiny Pilot only has addition and subtraction. That's all it can do. So when I ran through the randomness only benchmarks, I only ran it through 225 because it was going to take forever. But all 3 of them exhibit a really good range of randomness. And after running through all of them, 50, of course, would be perfect, picking numbers of 1 through 100. The Apple I Basic that Wozniak originally wrote for the Apple I computer, very good, right, almost dead on. And Tiny Pilot by Nick Vertus did not do that bad either. Coming in a third is Tom Pittman's Tiny Basic for 6500. But that said, all of them are more than random enough for any game or anything that we're going to do with this machine. It's time to run the carpet. We have Apple One Basic on the left, Lee Davidson's Enhanced Basic in the center, and MOSTech Microsoft Basic 1.1 on the right. Speeding up by 3 times, so as not to bore ourselves to tears, and easily, Apple One Basic is going to win this race. Not surprising, it's an integer basic. But Enhanced Basic is doing a great job. There's second place, and not far behind, MOSTech 6502 Basic by Microsoft, coming in here at third. Now, that's the result there. I wonder what's happening to our 2 slowpokes that are back on the first half of the course. Oh dear, not even halfway done. We have Focal 65 on the left, Tom Pittman's Tiny Basic for 6502 on the right. Let's speed this up to 15 times regular speed. And it's still a pretty dang close race, which is surprising. I would have thought Focal would be faster. A little surprised by Focal 65, but here are your times. Thanks for watching. Like and subscribe, all the usual YouTube stuff. I appreciate it. And I also appreciate you watching this video and going on some of these crazy journeys that I go on. It's nice to have the company. So until I see you all again, you take care.